Okay, let's start. Do you have any questions? All right, so continue where it was uploaded. It's under Zoom recordings on Canvas. Okay. Okay, so where we were last time. So we were discussing the ideas of, pricing in some like a review kind of thing. So we discussed, right, the idea of pricing as, so first of all, right, so I guess pricing of a derivative, right? So here we imagine that we have a fundamental asset, right, like a stock, big S. So, I mean, like, let's just not distinguish exotic option versus European option. Okay, let's just focus on European option for now to make it easy. So a derivative, right, is basically some asset whose value depends on like a more fundamental asset like a stock. Okay, and so we suppose that the dependence like this, so it's a European option. So to make it easy, so pricing, okay, is exactly to be able to, right, map the value in the future into any time in the past. Okay, so the task of pricing, right? The goal is to be able to, right, describe or to give, right, to describe psi, right, this function completely. And of course, right, not just completely, but according to some kind of criteria, right, that we think that pricing should follow, right? Anyway, okay. So again, notice that intuitively, because a derivative, right, takes its value from the fundamental asset, right, the functional dependence is still there, right, at any time prior to expiration, except that, right, at expiration, right, this dependence is easy or is specified by the contract, for example, like a call option. But prior to that time, right, prior to expiration, then that dependence, right, is not obvious. It's not clear to us what that dependence is. And right, our task in pricing is exactly to spell it out. Okay. Now, so what kind of criteria, right, that we went over last time? So there are two criteria, right? The no arbitrage condition. Okay. The idea is, and again, this actually has practical implication, that originally your market only has stock and cash, right? So originally your market, more like your market model, but your market, right, only has stock and cash, right? And my cash here is my lazy way to say it's a money market account, meaning that you can, right, put money in and accumulate, right, time value of money. But let's just call it cash. But when you do pricing, right, of the derivative, basically you introduce one more, right, asset into your market. Now your market has stock, cash, and derivative, right? And in fact, this is kind of true in real life too, in the sense that suppose that if you're at a bank, right, and some investor comes in and asks you to price or to sell them, right, a new derivative, a new product, right, a new exotic option or something that's not out there in the market, then essentially by pricing, right, you are introducing, because you're selling this product, you're introducing this product, right, you're the market maker, you introduce a new product into the market, which can be in turn, right, buy and sell, bought and sold. So the point is, right, that your market becomes more diverse, more rich, right? And so before, a portfolio in your market only consists of stock and cash. Now it consists of stock, cash, and the new derivative. So at least potentially, okay, that a portfolio can be formed, right? And of course, okay, also pay attention to one more idea, which is implicit here, but if you spell it out, it sounds interesting. That the whole point of arbitrage or making money in the market, right, even in trading, is to rely on correlation, right? Yeah, there's this idea of of quant trading that really kind of look out for like stocks that move with high correlation or with opposite correlations. So that's a different story. But the point is, right, you make money because of correlation. Of course, right, derivative and stock are super correlated, right? Because exactly that's how they are defined. So if you are not careful in your pricing, right, activity, then a portfolio can be formed using these two correlated assets, and right, will realize some risk-free profit, and that is not something we would like to see, right, in the market model or in theory or even in real life, because if there's anything like that, right? So by the way, again, right, I always emphasize that if you go out there and discuss things with people for your job, you want to be careful and not not say that there's no arbitrage in the market, because then you sound like a naive student, right? I don't know. It's just the way people act out there in the industry is they do believe in arbitrage. I mean, that's how they make money. But you want to describe things in the way that you understand it, right? I mean, basically arbitrage appears, but it probably will disappear very quickly because people will, right, take advantage of that, right? So the window of opportunity will disappear. But anyway, I mean, we don't want that even in our model, because we don't have that kind of, I'd say that we don't have the description of the window appearing and disappearing, that kind of thing, right? If our pricing is wrong, it will be wrong forever because we don't describe that. Anyway, right? So a portfolio may be formed so that, right, the value of the portfolio at the beginning is zero, meaning it costs nothing to form, right? On the other hand, this portfolio will always, right, lose nothing, right? So this is guaranteed to not lose. And also sometimes it wins, right? And this exactly is the technical condition for an arbitrage opportunity. Anyway, right, I'm not too concerned about this. I'm just trying to explain the idea that, so it's more important for me to, right, explain to you the idea that, first of all, right, by pricing, you technically might introduce a new product into the market. And second of all, right, this product is highly correlated with the original stock. So potentially, right, one can realize a risk-free opportunity. And so from that angle, it's pretty amazing that somehow, right, the theory that we come up with does not allow for this. Okay, doesn't matter how you think about your portfolio. So that's pretty amazing. But let's just leave it at that for now. Any question? All right. So the next one, right, is the replication condition, right? So replication condition actually is a different idea that says that the value, right, value of the derivative, right? The pricing activity, in fact, at any time t really, but you can say at time 0 should be right, should be enough, right? Should be just enough to form, right, a portfolio. All right. Of course, then the portfolio, right, consisting only of stock and cash, because that's the only thing you can trade in the market prior to having V. So that, right, pi t equals to Vt, right? And to emphasize this, let's just say probability of pi t equals to Vt is 1. Okay. So again, this emphasizes the fact that any time, right, at any moment after time 0, things become random, right? And this is exactly the idea of filtration, etc., that Professor Larson taught you, right? The only thing I'm interested in is you have to remember, right, that in the future scenarios, right, it's random. So when we say replication and that kind of thing, we say that it's replication under all scenarios. Okay, and that's super important, because if you make your portfolio and you just replicate under some scenarios, or you replicate, let's say, with 50%, that's not what we mean by replication, right? Replication means 100%, meaning that always, right, your portfolio match what you're supposed to hedge. And so just enough, right, of course, really means originally the portfolio is equal to the value of the derivative. So you use the money you gain from the derivative to form a portfolio. Okay. Anyway, so what else do I want to say? Now, replication, at least to me, is a more important idea, or a more practical idea, than the arbitrage. And again, actually, you should realize, right, and also, right, this term right here that we talked about also can be described under another term called, right, completely hedge, right? So the seller, let's say, right, when they do this, they completely hedge their exposure, right, to their payoff, right, to their risk of payoff in the future, right, their obligation to the option buyer. Anyway, so no arbitrage, like I said last time, is more of an academic consideration. Of course, it has real life implication too, but for various reasons, right? It's not kind of easy to think about that in the real market. On the other hand, right, anyone in the financial business, right, must think of replication in one way or another, right? Maybe they won't think of perfect replication, because again, that's a theoretical thing, but replication they must think about, right? Or hedging, right? Hedging is a very important business that everyone, right, trader, whoever, has to kind of deal with. Okay. In fact, right, I mean, like, right, the business of financial finance is to deal with risk, right, and hedging away the risk is exactly that kind of activity. So we'll go back to here more later. So that was right. Oh, and also let's talk about, right, let's remind ourselves of the prime, or the easiest example that we think of, right, to demonstrate this idea is the forward contract, right? And we say, right, this is the price. In particular, this is this. Okay. So the forward contract actually is important for many reasons. First, the pricing is super simple. Okay, so you must understand the principal pricing of a forward contract, regardless of anything else. I mean, people know Black-Scholes, but Black-Scholes actually is not that easy to explain. For a contract, you must be able to explain, you must understand why, right? Second of all, of course, forward contract is just a name for another, very similar product called the futures. And futures, of course, right, is traded very actively every day in the world. So you must know that too. What else? So yeah, we explained last time, I won't repeat it, right? So the why of the forward contract, at least from last time, you should notice that I explained it under the replication point of view, meaning I demonstrated to you that if you price like this, then you can form a portfolio that has this property, right, at time big T. I did not actually show you that that's a no arbitrage price, okay? And again, this is a sort of idea that I don't want to go into because, I want to discuss more practical things, but it's subtle, okay? Because no replication actually does not imply no arbitrage and vice versa, okay? Again, I hope you have seen that in Professor Larson's class in a little bit. But anyway, if I want to explain that this is a no arbitrage price, then it's a little different kind of argument, okay? And if you're interested in thinking in that direction, you're welcome to. But anyway, right, like I said, I like this idea better, so I'll just focus on that for now. What else, right? We'll go back to all these ideas again, but maybe let me talk about this question, why price, okay? So above, you can think of it as like, what is pricing? And now we want to talk about why pricing. Again, sounds like a naive question, but you guys are, I guess, spending money, right, learning about these things. At least you should know why it's done in the market or why people care about these activities, right? So let us ask maybe an obvious question, right? And if you know the answer, that's fine. But for example, when you price a derivative, right, does it mean that you tell, right? So suppose when we price a derivative, right? Does it mean that do we know the correct price of a derivative, of that derivative? So I'm not sure, maybe there's some myth out there, I don't know, stories, whatever, but I guess you might have heard of something like when people discover Black-Scholes, right? They apply Black-Scholes to, I don't know, the market, and they discover that, the price of Black-Scholes is different from the market price. They go and do some business and they become super rich, right? Whatever. So is that how we think of pricing? In other words, right, we use pricing to, I don't know, uncover some secret of the universe and become super rich. Is that what we do? Or in other words, right, why do we do pricing? Okay, so if you haven't thought about that, definitely contemplate that kind of question because, it's part of the activity that you do. Well, so I guess I want to correct that idea, if you have that idea at all, that pricing does not uncover any correct price of a derivative, okay? So in other words, when we do pricing, it's not to tell the market what to do. So no, not at all, okay? So what, in fact, when you go out there in the market, right, the activity of pricing, first and foremost, we always take the market price well, let me say almost always, okay? If available, as the correct price. No, and actually I intentionally use the word correct because actually correct doesn't mean much, right? So actually that actually is a academic prejudice actually, okay? When we do math, there is a correct answer and there's an incorrect answer. In business, it's hard to say there's something correct, right? What does correct mean, right? So there you could argue that, but I don't think, right? So here, the word correct is very, very vague, and I want to explain that. Yeah, but I don't think correct here means that either, okay? I mean, it means correct, it means that in our theoretical framework. In real life, it might not mean that. So, in fact, right, the simple answer to your question is the market is correct. That's actually the answer in a funny way, in a weird way. The market is always correct as far as we can tell. Okay, so we accept the market price, okay, as given, if you want. Again, right, the keyword is if available. I'll explain that. So what is an example, right? An example is if you go on Yahoo Finance right now and Google some option chain, okay? Let's say call option on Apple, they'll give you some price, right? Now these prices are not, right, done by some quant who sit behind the desk and tell that this is the price of the option. No, this is the price quoted actively on the market, okay? So, and any trader would need to accept that, and the trader would not go to a quant and say, can you give me a different price based on your model? That's not how it works. You accept the market price as given. Okay, then you ask, well, then what's the point of all these activities? Okay, why do you spend some time? Because, right, in fact, I mean, again, you should know something like this too. Historically, options were traded before, right, Black-Scholes were invented, or even the idea of mathematically pricing option was invented. In other words, right, people don't need you to trade option. People don't need quant to trade option, okay? They can trade options all they want. So price as being discovered by the market doesn't need quant out there. So what is the what's the role of the quants then, right? So the role of the quant is more subtle, or at least you should realize this is one of the role of the quant. For example, right, when we say that the price is like this, okay, this is correct, but actually, right, is more complicated than this. Okay, in fact, remember, right, the Black-Scholes formula says this, right? If we look at a call option, then VT, right, is ST ND plus minus K e to minus R T minus T, right, ND minus, where D plus minus is R plus minus 1/2 sigma square T minus T minus log of K over ST divided by sigma square root of T minus T. Okay. So this is right. This is the function psi right here. Now notice that, of course, right, it's correct that psi is a function of little t and s little t. But more importantly, if you want to write out the whole thing, it's a function of k R, T, and sigma as well, isn't it? Right? And again, right, it's obvious because, right, option is a idea. So, the price should be dependent on the contract, should it be dependent on the strike, should it be dependent on interest rate because you map future value to present value, should depend on how far ahead, right, the expiration is. And it also depends on the riskiness, right, of the stock, or depends on the volatility of the stock. Okay. Now, so when you stare at this for a little bit, you will realize that, right, among all these so-called parameters, right, we don't think of this as parameters, these are variable, but these are parameters, right? 3 of them, right, are observable. I mean, or are actually observed, right? You do know what these guys are. I mean, right, these guys are specified in the contract and are, right, I mean, you can read off on, the money market. But sigma, right, is not observable. In fact, I mean, you could argue, and if you're a little bit more sophisticated, you say, yeah, well, I could look at the historical, right, fluctuation, right, of the company itself and deduce sigma. So if you say that, you're already more sophisticated, which is good. Well, and we can go back to that later. But let's take a non-sophisticated point of view, right? That if you look at a company, it's hard to say that this one is 30% volatile or 20% volatile, et cetera, right? It's not observed. It's not observed. And so, right, the activity of pricing is like this, right? That if you do somehow have a formula that sensibly, right, consistently tie together the future value to present value like this, okay? And by sensibly, I mean it follows all this, consistency, right, rule that we looked at theoretically, okay? Then basically you have a function, right, that maps all these parameters to a value, okay? So all you want to look at is this is a function that maps, like, let's say 6 parameters, 6 values to a single value, which is price. So now, right, the problem is you don't look at this in the forward direction. You don't view this as a forward map. In other words, you don't look at this as you plug in these values and it get out price. Yes, it's supposed to do that too, but you use this in the opposite way, okay? Remember, we say we accept the market price as given. In other words, once you have this tool, then you set, right, this to be equal to the market price, which is, right, clearly also observed, okay, and given. And when you look on this left-hand side, right, you have all of these guys known, and this is unknown. And so basically, right, this is like an equation, okay, of sigma. A highly complex equation, by the way, right, because, this function is complicated. But nevertheless, right, you could solve for sigma in the above equation. How? Well, this is where, your numerical analysis comes into play, right? Using some numerical method. But once you do that, then you have, right, practically deduced sigma from the market price of the derivative on the stock of the company. So in other words, you have found the implied volatility based on the option price, right, of the company, right, on the stock of the company. Okay. And this is, again, a highly valuable piece of information because, and again, papers have been written about it as well. In other words, right, people view, right, like buying and selling as reflected on how the market view how valuable and how risky a company is, right? And all this information, okay, you probably have heard of this before, is very complicated to be gathered. In other words, right, different pieces of information come together by people doing buying and selling, and price is discovered, meaning that, you know, the price of the stock is discovered, right? People will reflect on how they think the company is from the price of stock. Of course, because the option price also is dependent on the stock, is also directly influenced, meaning the option price also reflects how risky, right, the market think our company is. So by having a sensible function that, right, price that maps the value, right, of the current stock and etc. to that market price, you can uncover how the market, how risky the market think about this, how risky, right, the market think about that company is, that stock is, right, and that sigma implied, right, is a very routine calculation that people always do to, you know, from whenever they see a option, when they look at the option price of the company. And so from the implied volatility, right, there are many other pieces of information that people will also do with the implied volatility. For example, they will price further option based on the implied volatility or on the implied surface. Okay. So anyway, for now, let's not pursue that idea further, but let me recap, right, and say that the idea of pricing, right, most of the time is to uncover implied information about a stock, about a piece of asset, okay, like some unobserved parameter on the model, right, that you don't see. The activity of pricing is not about telling the market what to do or to discover the price. No, right? The market does the price discovery by buying and selling, right? The task of the quant, right, is to come up with a sensible model on the stock and a sensible piece of pricing, right? In other words, this function right here that connects future to present price. And then from that model, right, use some numerical method to uncover, right, the implied, the unobserved information about the stock, for example, implied volatility. Is that clear? Any question? All right. So maybe let me show you, right? So here is the Python notebook that actually came from Alvin, right? Alvin gave a talk last fall, if you remember. And exactly, you know, the whole piece of Yahoo Finance here was written by him, and I took that and modified a little bit for the other time series stuff that we looked at, right? And so if you recall, right, he was exactly look at the S&P 500, right, on that day, which is, 2021, right, October 25th. And he was looking at the option price, right? Let me see if this is the, yeah, this is the call option price, right, on the S&P 500 with the strike, right, and the bid-ask price, right, for the option, okay, and there was a what was the expiration? Let me see here. Oh, I think the expiration is probably included in here. I'm not so sure. Expiration date 1, which is, oh yeah, all these expiration dates, okay? Right here, up here. Anyway, right? So these are the quoted option price on that date, on October, on the on when he gave the talk, and oh, actually when he ran the code, I guess. And then down here, right, was where he applied the the implied volatility function, right, where I think he was just doing some sort of um, bisection method on the Black-Scholes formula, right, and found the implied volatility at different price of the option. And here, right, is where he plot, right, the implied volatility for for the option with the expiration on the October 25th. Okay, like this with different strikes. And this is where he demonstrated that this is a volatility sum, right? But that is exactly a very routine piece of code, right? That can be written that takes on the option price at many different strikes and find the implied volatility, right? And plot it like this. Now, of course, people also do this with the expiration date, right? And so if you do that, then you get a 3D surface called the implied volatility surface. So this, I posted this right on the course canvas on Python code, so you can take a look again. But this again, right, demonstrated very precisely a typical activity where people do, right, to find the implied volatility. This is finding implied volatility for many option price, right? In the notes I just written for one option price at one particular strike, for example, but here he found it for many different strikes at one expiration date. Okay. Okay. Any question on this? So that demonstrates, right, this activity for you. So now, that said, right, I want to say there might be one occasion where, so here, again, I want to emphasize that most of the time when you do pricing, you accept the market price, okay? And you want to discover implied parameters, implied information about the market, about the stock. On the other hand, rarely, occasionally, you could really, one may use the pricing formula, the pricing technique to discover or to prescribe price for a illiquid product. Okay, so the activity of pricing, so that you actually use that to tell the price of a product, of a new financial derivative, can be sensibly conceived, right? But you have to kind of be very careful on when you use that. So basically, you will never use pricing to discover the price of a liquid product. So that's why I say if the market price is available, then you do not use pricing to tell, right, the pricing formula to tell what the price is. But, for example, right, there are some products that are not sold on the market. For example, a client can come to a bank and say, I want to buy a new product, okay, some exotic option that is not being sold. That's why they come to the bank, for example, in the first place. So then the bank, right, if they want to sell this to the client, then they must come up with a price, right? And that you can imagine that then the bank would ask the quant team, right, to investigate on that product, on the structure, and come up with a price, right? So this price is going to be a new price because the market doesn't have a price for it. So then the pricing technique in that case, right, you can imagine that that's a sensible way to use a pricing technique. If this is a product that's not being sold on the market, okay? So that's why I use the term illiquid. Another sensible scenario is this, and you have to be careful, right? Once you understand the idea, you can say it in many ways. When you look at a option on the currently liquid, when you look at an option price, right? There are many. So let me show you. Maybe for example, let me see if there's Yahoo Finance here. Yeah. So right, when you look at Yahoo Finance, this is just on the website. At different strikes, right? At different strikes. Oh, here actually, yeah. Sometimes at some strike levels. Let me see here. This is somehow they have a lot of open interest. Yeah, here, right? For example, this is Apple put option. And you see that, right? Open interest and volume means that how much they're actively being traded, right? And you can see that for the strike that's in the mid-range, right? There are a lot of volumes traded, like 15,000 right here, 20,000, right? But if you go to the more extreme range, like 245, you see that they're not being traded at all, right? The volumes are very small. So you want to pay attention to this idea too. So in other words, right, the market price for the mid-range strike, right, like this, is more trustworthy because it's being actively traded, right? So it reflects the market information. While something like this, right, you see the implied volatility here, you see that it's 130% forever. So the information here may not be that trustworthy. In other words, right, because no one is interested in buying the strike at these extreme levels, right? Then basically this is where the area where I call is illiquid, right? So it's conceivable that one can use the pricing information to extend, right, pricing in the mid-range, right, using the implied volatility found there, right, to price the option out here, right, rather than take the market price as given. Because here, right, it's not being actively traded, so you don't have the market information out here. So that's one sensible idea, right? Now, I don't claim that I know that this is what people actually do in the market, right? Maybe they don't do that at all. But an example of an illiquid area is this area too, right? So even for options that are actively being traded right now in the market, it's not that they are being traded actively at all strike levels, right? There's some strike levels where, the information is less trustworthy, right? You see it right here. And in fact, right here, the implied volatility is 0%. It's not because it's zero, right? Implied volatility, just because they have no information, okay? So there are those subtle ideas that you want to pay attention to. So when people find implied volatility, right, they typically rely on the mid-range area for more reliable information, for example. Okay. Cool. Any question? So I hope the above, right, covers basically the why of the pricing, okay? So mostly why should be about uncovering implied information about a stock rather than, okay, telling the price for an option. You could also, right? I would just put it here, so maybe we can come back to this idea later. It's not more advanced, but kind of build up on the implied volatility idea. You can use it to kind of find the Greeks and other information, okay? Again, based on implied information. So basically, you just build up on the idea that once you have this formula, right, for pricing, then you can use that to uncover some other information, such as the Greeks, which is the sensitivity of the stock to the underlying parameter, to the change in the underlying parameters. Okay, using this formula, using mathematical techniques, right? Again, these are very valuable information that a trader would want to have access to, but it's not readily observable in the market by just looking at price. So they have a bunch of quant team, right, putting mathematical formula together to give them some good estimates, right, of what these quantities look like. So that's what, okay, that's what the use of the mathematical theory is about, to give the the trader, the market participants, some information about the stock that cannot be seen on the market price alone, but requires some model, right, to uncover it. Okay, so again, we'll come back to that idea later, but keep that in mind. So I want to kind of go back to the idea of pricing yet one more time, right, on this idea, right, another property of pricing. So all these things I'm discussing are very, very simple, right? But I think it's fundamental that you get the right angle. So let us look at the forward contract, okay? And look at how we price it. Okay. Now I claim that, right? This pricing is very natural. Okay. In other words, I do recall that when I asked you guys what is the price for the contract, most people don't know, which is okay. But I think this is also because you try to think about academically or theoretically, whatever. Okay. If you ask any trader or anyone in the market, in the business, they will tell you immediately what this is, even if they don't know Black-Scholes formula. Okay. In other words, this price is very simple to anyone who has been doing trading or doing some business in the market. Why is that so? It's simple and natural without any mathematics. That's what I'm trying to say. The reason is this, right? First of all, it's very simple to think that the price of a stock in the future, so right, the thinking, right, is pricing means mapping the future price to future value to present value. Okay. So now the future value of the stock, right, is worth how much in terms of current value, and future value of a piece of cash is worth how much in the present value. Can anyone tell me? In other words, right, if I have a derivative like this, what is its current value? And if I have a derivative like this, what is its current value? You mean for which one? For both? Yep. So, right, exactly that. this is this, and this is this, right? Yep. So this, right, actually these two pieces are two fundamental, right, kind of piece of the financial asset, if you will, right? This represents a bond, right? This represents a bond. Then pricing a bond, right? I mean, if we kind of think of, right, the risk-free rate is constant, which is not true, right? We can model a risk-free rate as a stochastic process, but more on that later. If we look at the risk-free rate as constant, then the price of the bond, right, is just mapped by discounting using the risk-free rate. On the other hand, the stock, right, the future price. So again, right, it's so simple that it might slip your mind, but a future value of the stock, right, mapped to the present is just a present value of the stock. Okay. Again, it's super duper simple, but there may be some silly idea like this, if you will, right? That there is a story that says, suppose that, let's say, I don't know, you take anything you want, Metaverse, Bitcoin, whatever, right? Or let's suppose you say Google, right, is very profitable. And in fact, someone tells you that Google stock will definitely increase with probability 1, right, in the future. How much are you willing to pay for a share of Google now? Okay. In other words, right, for the sake of discussion, let's suppose that right now, right, one share of Google is worth, let's say, $1,000. Okay, that's one share. So in this question, suppose that the person says, right, I do know by insider information, whatever, right, that Google stock will guarantee to go up a lot. Now, are you willing to pay, let's say, $110 for a share of Google stock to have a chance that it go up in the future? Yes or no? Will you pay $110 for a share of Google? But there's, of course, right, with the information at Google, yeah, the answer is no, right? That's just a silly thing to do because Google is being traded at $1,000, right? So you can just go ahead and buy $1,000, right, for a share of Google. Why would you pay more? So that is exactly this idea, right? The future value of the stock doesn't matter how high, how low it go, right? It's the present value of the stock. Yes. Notice again, it's not that simple because, right, this is stochastic, right? This is random. So anyway, one more thing is this, right? Sometimes these ideas sound reasonable to some people, actually, right? Some people will say, that's not too bad. I'll pay more, right, to get a share of something that will go up in the future. But if you think like that, then actually this higher price is being paid because you have no access to this price to begin with. In other words, right, you pay a higher price because of the liquidity condition of a stock. Okay, so that's also another kind of like unsaid assumption about pricing activity. When we do pricing, we always assume that stock is liquid, meaning you can buy it, sell it all the time. It's always available in the market to buy, right? If you put in the illiquidity of the asset, then that's a very complicated thing that we don't, right, model, in our context. Anyway, right? So these are the two fundamental pieces of information that, if you think about it, it just makes sense. One more thing, right? When you look at like this is exactly the martingale condition that you should have learned in Math Finance 1, right? That basically the future discounted stock price is the current stock price, right? So basically, again, we'll talk about martingale pricing later on, but I want to emphasize this kind of idea that maybe when you do martingale pricing, you think that somehow because it's martingale, then the price must work like this. In fact, right, the truth should be the opposite, because pricing must work this way, right? No one in the market would sensibly pay more or pay less for a stock that is currently at 1,000. Therefore, the only model of pricing that corresponds to this idea in the market is martingale pricing. Okay, it's not that we use mathematics to uncover a law of finance. The law of finance dictates, right, what kind of mathematics we use for our pricing. Okay. Anyway, right, once you understand this very simple idea, then this is also very simple. Why now, right? So exactly, you see, this is a combination, right, of, if you want to look at like this, right, a forward contract can be looked at as longing one share of a stock and shorting, right? You can call K shares of the bond at face value 1, or one share of the bond with face value K, whatever you want, right? But long one share of stock and short, let's say one share of the bond with face value K, right? That will give you a forward contract. By the way, right, that idea is exactly the idea of replication as well. In other words, I replicate the forward contract by some position on the stock and some position on the bond. And so, right, it should be very natural for anyone that if you do replication like that, right, in other words, the idea of replication pricing is like this. If I have some stock, right, some asset in the future, that will be something like this. Okay, so basically, if I have a financial product that can be broken down or that can be replicated by two small products, right, then the price at any time before that should exactly match like this. Okay, and you can throw in some many shares as well if you want, right? C1, C2. Is that okay? So in other words, right, notice that it implies like this, right? So if the future value match like this, then the current value also must match like this. Okay, so what that says is that pricing is a linear activity. Okay, in other words, right, again, it seems like a very simple and, I don't know, nothing to talk about piece of mathematics, but it has implication, right? The implication is that if you know the price of the simple pieces, then you can easily find the price of the more complex piece by replication. Okay, like this. Now, where do you see some idea like this? First of all, right, like I said, you see it in the call option. Sorry, in the forward contract, right? You replicate the forward contract by using these two simple pieces. Therefore, the price of forward contract anytime would be like this. Okay, for the price in any time before expiration. Now, you can see this, right, more non-trivially in some more, unusual financial product like a strangle we talked about last time, right? Or a butterfly. Okay. So what's the point of these guys? So these guys are less, I don't know, are more fun, right, or more interesting financial product than just put and call option, right? So I'll just say they are more sophisticated if I want. It's not really that, right? Than call and put, right? On the other hand, right, if I know how to price call and put, then I can price these easily. Meaning I don't need any extra work. I don't have to redo my work to price strangle and butterfly. If I know how to price call and put, then I can price strangle and butterfly very easily. Okay? Can anyone tell me why? Why can I price this easily? I don't need any extra work if I know how to price call and put. No, it has nothing to do with no arbitrage. Exactly. Actually, exactly, right? So that's the whole idea, that I can, and the term is synthesize, right? I can synthesize these out of call and put. Okay. For example, can anyone tell me how I synthesize strangle out of call and put? This should be obvious. How do I synthesize a strangle out of call and put? Right, correct, right? One put here and one call here. So clearly the price of a strangle is just a price of a put and a price of a call, right? A butterfly is a little bit more sophisticated, right? But one call here, one put here, and minus, I believe, right? Two of something here, right? You can look at your homework. But anyway, so the point is, first of all, whenever you synthesize some product out of new fundamental products, then you don't need to redo the whole pricing at all. You just use the pricing of the simple product, right? And use linear combination to price a new product. Okay. Now this sounds again very simple, but it contains two ideas. First of all, right, many interesting products, right, can be formed by calls and put. Okay, and what do I mean by interesting? By interesting, I mean this, right? And here's where you want to pay attention to finance and not the math. For example, the math just say that you do this, right? A function of a stock. So in theory, you could do something weird like this: st square, square root of st, etc. Right? Now, mathematically, who cares? Because these are function of st. But in terms of finance, then someone as a trader, they will ask, yeah, looks cool, but why do I want even to buy a product like this? What does it do to me? Right? So that would make you sound like a nerd, meaning you just say something without understanding the implication of what you say, right? So again, pricing can go through with any of these kind of function. But right, why would a trader care for a product, or someone care for a product? They buy a product because it serves some risk purpose, right? It fits some risk appetite. Okay. So for example, we talk about how strangle, right, fit the risk appetite of someone who think that the stock will fluctuate a lot, right? Volatility will increase in the future. Butterfly fit the appetite of someone who think, right, that the volatility will be small in the future, right? So when you come up with a product, right, at least for financial conversation, you must explain what that product is doing, right? For what kind of risk appetite profile, right? And so call and put form interesting products in that sense, okay? That it creates new risk appetite, right? Or new product that serves some kind of risk appetite. The most interesting of all, and this is very advanced, right? Most advanced, or I'm not saying most, but like advanced out of this class even, is something called a variance swap. Okay. I'm sure there are more advanced product than variance swap. Okay, I'm not saying variance swap is the most advanced product out there, most advanced in terms of what we will discuss in this class, and we won't even discuss this. But you're highly encouraged to look at, right, the variance swap. And the variance swap is a very, very important product, okay, that people trade, right? Trader trades. Actually, they trade volatility, they don't trade variance. But it is formed on the basis of a variance. So if you want to trade the volatility of one company to another, for example, right? Suppose you want to buy volatility. What does that even mean, right? Because volatility clearly, right, is an observable thing. It is not a product, right? But people want to buy volatility. For example, if they think volatility will come up, will go up, right? So that calls for some people to synthesize something that behaves like volatility, right? And so that's more advanced. But if you want to buy something like the variance, meaning the squared volatility, you can synthesize it out of calls. But the calls here will be infinitely many calls. So anyway, right, very, 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 very advanced. So I just want to say that. But the important thing is it just come out of the calls. So these interesting products can be formed right out of calls and puts. So your Black-Scholes formula, right, for calls and puts are not that simple. The reason is, of course, you learn simple formula, but if you put them together, then you can price some very interesting products, right? That financially does something. That's what I say. So calls and puts are fundamental in that way, right? And of course, the second one is just that these products, right, don't take extra time to price because you already know the calls and puts, right? If we already know. Calls and puts. Okay. So actually, that's not true for variance swap because the variance swap is infinitely many. So yeah, actually, it's true though. If you read the article on variance swap, you'll see that most of the time the articles spend time on how to replicate the variance swap by calls and put. But once they do that, then they say the price is straightforward. Okay. So anyway, so this is these are important ideas I want to bring up. In fact, right, more importantly, even that to even build on this idea more, that we only need to know the price of call. Put price follows automatically, right? Can anyone tell me why? Exactly, right? So put call parity, and what is that? What is put call parity? By the way, right, put call parity is a fundamental thing that anyone must know if they want to get a job. What is put call parity? Put call parity says call minus put equals to forward. Okay. Why? Mathematically, it's very simple. Call is x minus k plus. Put is k minus x plus or x minus k minus, if you will. Right? And so when you do this, if you do any math, right, the positive part of the function minus the negative part of the function is just a function itself. And so, of course, right, if you stare at it for a little bit, right, this is the payoff for the call, payoff for the put, payoff for the forward. So there you go, right? This is another mathematical simple thing, but in terms of finance, right, you're saying you can synthesize a call by longing a forward and longing a put, and of course you can synthesize the other ones, accordingly. Okay, and right, pay attention. The forward, as I explained to you, can be priced without any model. So all you need to do is to know how to price one of these guys, and the other one will follow automatically, right? And traditionally, people just look at the call. But of course, you can also price a put, and then the call will follow. All right, any question? So, okay. So the idea of synthesizing, right, or replication is very important. In fact, right, the so-called, God, it's been a while. Somehow I just forgot the name of these things out there. Not mutual fund, but the ones that used to replicate gold and even the SPY, right? What are they called again? Somehow the names just slipped my mind. But this fund, right? That ETFs, exactly. Thank you. It's been a while for, yeah, the ETFs, right, is exactly right. They have been super popular for the last 10 years or so. What's the reason? The reason is synthesizing new product, right? Synthesizing things that people want to buy, right? That they cannot put their hands on, right? Before that, right? If you want to buy the S&P, you want to buy healthcare, right? As a market, well, before you cannot do that if you are a small-time trader. Now you can go on Robinhood, right? And buy all these things, right? Not that I want to endorse you to do that anyway, but I'm just saying these things are super popular for that reason, right? That allows people to buy a lot of things that they cannot have access to before. Okay, yeah, thank you for that. Somehow that slipped my mind. Okay, so now let us go to the next idea, right? So the idea, so I'm done with pricing, okay? So that's just a review of pricing and the ideas of pricing, which again, I emphasize is important. Now I want to talk about stock models, okay? And first of all, let me just explain very briefly, right, why model. Maybe is still the idea, right? You just take the stock and you start modeling right away, but why model? For example, you should realize certain things like this, right? To price a forward, right? We don't need any model. Okay, it's very important. You realize that. So you don't need Black-Scholes and all those fancy thing to say this. In other words, right, futures, I believe, has been traded by human for the last 4,000 years or so, or whatever. Futures probably have been used to price, the ancient Egyptian, I think, have been using futures before, or whatever. But the point is that people know this, right, before mathematics and Black-Scholes. The reason is why, you see, all these concepts are pretty simple to anyone who has been in the market, right? So there's no need for you to say that stock behaves in a certain way, right? The future value, right, of the stock price can be mapped to current value of stock. Future value of corn can be mapped to present value of corn, etc., right? On the other hand, if you move to more sophisticated product, like a call option, then suddenly, right, replication using buy and hold is no longer possible. Okay. In other words, suppose that you say you have X share of the stock, right, and cash and some Y amount in cash, and you try desperately, right, to match this payoff, right? That's replication using stock and cash. Then you quickly realize, right, that again, like I said before, the tricky thing is this must be true for all stock price in the future. In other words, right, this is a million equations waiting for you to fulfill. But you quickly see, right, this is a what? This is a linear equation, right? Linear function in terms of S. On the other hand, this is a non-linear function, right, of S. So there's no way, right, under the sky that you can match this and this, right? Now, Of course, right? So I just want to quickly say, right, it's non-linear because of that, right? So this part is linear, this part is linear, but if you mash them together, it's non-linear, right? So that doesn't mean that, right, that there's anything wrong with this whole idea. It's just that buying a whole portfolio won't work. You need to do more dynamic trading, right? That dynamic hedging. But when you do dynamic hedging, or in fact, another way to look at it like this, right? How can you have a hope to match this something? Or how can you have a hope to keep track of the stock? So you need to simplify, or you need to specify more about the behavior of the stock. Okay. So in other words, when you do pricing and you don't have any model, that's really cool. Like, you don't say the stock has to do certain things, but if you want to price more sophisticated, right, product, then right, to let your math do whatever it needs to do, like replication, whatever, you cannot just say the stock can do whatever it wants. You can still be general about the stock, but you need to be more specific now, right? You need to say that the stock can behave only on this way, that way, etc., so that I can, describe it under this, assumption, which is really, right, your model. So I want to review this real quick, right, and look at your simplest model, which is the binomial model, right? And you learned the binomial model, I'm sure, right, from Math Finance 1. And your binomial model goes something like this, right? So SK plus 1 is SK times, right, either U or D, right, like this. So in other words, you can say that, right, SK plus 1 condition on SK, right, is SK times some random variable called XK, if you will, where XK takes on two values, U and D. Yes. And then if you keep on doing that, right, then you got this binomial tree, right? I don't have to repeat it for you because I'm very sure you're familiar with this. Now, let me just ask one thing first, right? When you look at a model, you must understand what it means. So what are the meanings of U and D? So you do U and D, right? What are the meanings? And here I mean the financial meaning, right? Not the mathematical meaning, because it's clear what it's doing, but what's the financial meaning of U and D? See, that's math, right? But more financially, right? It's not just price go up and down. It is more special than that. Okay, so to save us time, the meanings of U and D exactly is about the returns stock. Okay, so fundamentally, we'll talk about this later. When you look at a stock, you don't necessarily care about the stock itself, but you care about its return. And there are two concepts of return: log return or percentage return. Okay, percentage return is the stock price over a period of time, right? So DT is some time interval. Log return is like this. Okay, and they're closely related, but not the same. And we'll explain that later too. But give me 1 minute, all right? So if you look at this, right? So clearly in the binomial model, you model stock in, several time periods, right? Like a day or a week or a month, whatever, which you don't really clearly specify. But if you look at this, right? So let's say SK plus 1 minus SK over SK, right? What do you get? Well, clearly, right, SK plus 1 is SK times XK, right? So it's going to be SK right, times xk minus sk divided by sk, right? So that's going to be xk minus 1. Now, what is this? This is your percentage return, right? So xk clearly is the u and d. So in other words, u minus 1 and d minus 1 is your percentage return. Okay, this is your percentage return when the stock goes up. This is your percentage return when your stock goes down. So when you do U and D like this, I know that, right? It's just simply modeling the stock price. But as I'll explain to you next time, it's not that simple, right? It's more subtle than that. I want you to start taking the point of view that when you do this, you are modeling the returns. In particular, you're modeling the percentage return if you want. You can look at this as a modeling the log return too, doesn't make a difference. But right, you are fundamentally modeling the return and you're not modeling the stock price per se. Okay, so that's enough for today. If you have any questions, I answer. If not, I'll see you on Thursday. Okay. Don't forget you have a review session in the afternoon.